Hello, today we're going to talk about fast ambulatory simulation system for cardiac patients using GSM network and ECG signal.
The development of rapid simulation system for cardiac patients using GCM networks and ECG signals represent a significant advance in ambulatory monitoring of cardiac conditions. This project focuses on the integration of MATLAB and Simulink tools to simulate and analyze the transmission of Syntec ECG signals over a GCM network, considering the typical complexities and challenge encountered in real environments. Next, please. This project focuses on simulation using MATLAB and Simulink to model the transmission of ECG signals over a GCM network. A synthetic cardiac signal is generated in MATLAB and integrated into Simulink to emulate transmission over simulate logs of a GCM network. This includes GMCK modulation process, noise addition, signal filtering, and the modulation to evaluate the integrity and quality of the post-transmission. Signal parameters such as A diagrams, constellation diagrams, and bit error rate or BER are analyzed to understand the system performance under different noise and signal to noise ratio conditions. Next, please. In first, the configuration of GCM circuit was carried out in Simulink, where we can see the following blocks with their configurations for what they requires of use. Next, please. First block of Simulink is to assign the ECG signal synthetic, and we can see the intro or GCM configuration. Next.
After that, as my partner said, we added a block. A block was placed to normalize the ECG signal with a minimum value of 0.6 and a maximum of 2.5 volts, so that the result enters the next block integer to bit converter and converts the signal to bits that will reach a value of 256.
Then we pass it to a converter integrals to bits, where the most important thing is the number of bits per integral, in this case 8 bits. And this shows that our network configuration is exactly as we want it, in addition to giving us the visualization of a scope as in the figure shown. Next.
When we reach the fourth block in our diagram, we have a GSMK modulator, which was used to modulate the bit sequence that comes out from the third block using the Gaussian minimum shift keying modulation technique. This modulation is the main or the most important part of our GSM system, since it is one of the characteristics of the signal and is modulated in this format. Its parameters are reported in our project, and the output of this block is visualized in the eye diagram that we have here in the slide, and the constellation diagram also that we can see here. In the previous diagrams, we can see that the transmission signal has no noise at all, having a clear figure of the eye diagram and a sequence with a certain circular order in the constellation diagram. Then in the next block, which is block 5, of our GSM system, we add an AWGN. This is an additive white Gaussian noise block, which in this case is used to simulate the effect of additive white Gaussian noise in a GSM type communication system. This was configured with the parameters also reported in the project, in addition to obtain its AYA constellation diagrams, where we can see the comparison from the previous figures, that the signal already has added noise. In this case, the eye diagram can no longer be seen as well as before. Adding the noise, and in the constellation diagram, we can see that it still has a circular format, but more dispersed in all directions. And this to make our requested GSM system more realistic. Something important to note here in this case is that the SNR it has a value of 10, which means that there is a moderate signal to noise ratio. So the signal of interest is stronger than the noise, but the noise can still have a significant impact in the signal quality. Then, well, for the bit signal, after the filter that it was a bandpass filter, this signal is sent to a demodulator where with the same parameters of the modulator was configured, and the signal is demodulated to recover the sequence of transmitted symbols. And now in the final stage that is the 8th block, with the modulated signal from the previous block enters the bit to integer converter block, where we go from the bits to an integer. The parameters have to be the same as the integer to bit converter block. By doing this, we obtain the final transmitted signal, which, as we can see here in the slide, has no errors and has been transmitted correctly, being identical to the signal sent.
Finally, a change were made to signal to noise ratio for the telecommunication system. This though, so that we can see the impact of this and have a clearer idea of a graph we need for the BERT. To calculate the BERT, the MATLAB tool called Virtual is used with the data from our simulate system in Simulink is acquired by it and shows or a graph of the relationship between the pair of your system and its signal to noise ratio as can be seen. When the signal to noise ratio is 1 decibel or GSM network is poor and ineffective. However, with 10 decibels, the network is better. Ideally, it will be 18 decibels or more, having a system without transmission error. Next, please. In conclusion, the proposed GSM system is efficient from 10 decibels signal to noise ratio, making the integration of Gaussian minimum shift keying or GMCK with GSM networks demonstrate a robust approach for wireless data transmission, particularly in healthcare environments where reliability and safety are paramount. Leveraging GSM infrastructure enables real-time monitoring of cardiac patients, improving the accessibility and timeliness of healthcare service. That's all. Thank you.
Thank you.